Good evening, and thank you for joining today's webinar, Solar PV Site Plan Review Training. This webinar is brought to you today by USES, that is a 501c3 nonprofit. To donate, go to usesusa.org. Today, this training session will discuss the basic legal framework for performing site plan and special use permit review for solar projects. It will identify important substantive issues for reviewing boards to consider when reviewing and conditioning solar project approval, and discuss accounting for fire and building code compliance issues in approvals and approval conditions. Following this training, municipal training certificates will be available upon request. Please send USES an email to eva@usesusa.org indicating your request for a training certificate. Lastly, Friends of USES October 2021 grassroots gathering titled Debunking Misinformation will be this Wednesday, October 27th from 7 to 8:30 p.m. on Zoom. This gathering will be a question and answer to assist in addressing misinformation and myths that come across when discussing solar energy projects. The invitation will also be dropped in the chat below. So we thank all of our presenters for being with us today. We are going to start with Dwight Kanyuck, who is an attorney with Knauf Shaw LLP in Rochester, which focuses its practice on environmental, renewable energy, land use, and municipal law. For more detailed bio, please go to the chat below.
Thanks, Jenna, and thanks for everybody for all the presenters and for all the folks listening in out on the web. My usual disclaimer: 1, this is not legal advice, and 2, the medals behind me were not earned by me. This evening we wanted to talk about, at least to start with, just kind of set a framework, a baseline for, what is site plan review, what is special permit review for solar projects, typically for larger projects where they be community solar projects that come before towns. Usually there's some framework where either a special use permit is required or a site plan review approval is required, or often both, especially for the, I would say, projects in the community solar range, like 2 megawatts and above. What I want to talk a little about is just the basic legal framework. What's the distinction between special use permits and site plan review, and then talk about some of the nuances of those reviews, and as well as just a typical process, perhaps a simple one, and highlighting some of the things that come up with solar projects that we're going to get into later with the other presenters, where if the issues can be at least raised and discussed with the proper people at the site plan review stage, it can head off problems in the field if the projects are approved, and ensure that everybody's expectations on these projects are met. So first, what's the difference between site plan review and special permit review? And from a basic standpoint, it's about the use that is being considered. So in a site plan review, the use is permitted under the zoning code. It's allowed, although it's subject to certain requirements. The requirements can be waived by the approving board. Usually the approving boards are planning boards, but fundamentally the use is allowed in the zoning district, though the use in the manner that it's allowed is subject to certain requirements. But I think fundamentally the site plan approval process can't be used to prevent a particular use. On the other hand, a special permit, in the special permit review process, there's a presumption that the use is permitted, but it's with conditions that are established in the zoning legislation, and all of those conditions have to be met. Is the one case I cite here indicates even if one condition is not met, then the use is not permitted. So special use permits are, the use is allowed, it's presumptively allowed, but there are certain instances where in a particular situation, if it is incompatible with the neighborhood and it doesn't meet the criteria in the enabling legislation, that permit would not be issued. So it's subtle, but there is a distinction here. So a lot of the the solar laws that are in place, I think the distinction with those that, let's say there's only a site plan approval required versus a special use permit and a site plan approval, that would imply that those projects that are only need a site plan approval, presumptively the solar project is permitted there. There are some design requirements. Some requirements can be waived, but fundamentally that use is allowed there. So the impacts on adjacent uses associated with that have been presumably assessed at the time of the zoning, and that use is allowed. With a solar project with a special use permit, there's more leeway as to whether that project is allowed in that area, but presumptively it is allowed, but it does have to be deemed compatible with the neighborhood. So what's the scope of review in each of the two instances? So first, like site plan review can really cover, and the quote here is from the statute in the town law. It can encompass a whole range of issues associated with the land use, especially with an emphasis on ensuring that the adjacent properties aren't negatively impacted by the project. These specifics can be enhanced in the local law. They often are. In the case of solar projects, there are very specific requirements, whether it's undergrounding of wiring, particular setbacks and such with solar projects that aid in the citing of the review, whereas perhaps for your typical development, it's a little more gray as to what some of the requirements might be, and it's left to a little more discretion. For a special use permit review, again, it's focused on the use. There are criteria that the enabling legislation, usually in the zoning code for that special use permit, requires as far as consideration before approving that use. Usually there's both an approval and there's both approval for a site plan as well as a special permit when there's a special permit involved. So all those design considerations are still included in the overall review, but the special use permit is focused on the review and ensuring that it's compatible with the neighborhood. And finally, just want to talk a little bit about the typical site plan special permit review process. This is, I think, a simpler one, which is probably often the case with some of the towns where the project is being cited. Some of the smaller, more rural towns that they have, I would say, what I would call a single-step site plan or special permit review process. Some will have preliminary site plan. I think more typically for the solar projects, this type of scheme is present. Again, this can be tailored through the zoning code to have different review requirements and perhaps different timeframes. For instance, in starting with the submission of the application, many solar laws now have been I think the specifics on the applications have been much more comprehensive. So there's I would say a preliminary step where there's an assessment of whether the application is complete. Sometimes that's the code enforcement officer's job to review that. Sometimes the towns will engage a consulting engineer and legal assistance to review the application to ensure it's complete, especially with respect to the seeker issues. And I'm not going to get into much detail on the seeker issue because that's probably a webinar in itself. And in fact, we had a webinar on seeker for solar a few months ago. So go check that out if you want to know more about solar. But there's a whole, as anyone who's done these reviews before, there's the whole cloud of seeker kind of hovering over the whole thing, which has its own approvals and review cycle associated with it that goes in a great sense in parallel with the site plan and special permit review process. So usually the local solar ordinances, especially the ones that perhaps have been more recently updated, have specific application review requirements it's either deemed complete and it proceeds to the next step, or it goes back and more information is asked of the applicant. So then the next step, depending on what the nature of the approval is, there's a public hearing scheduled. In the town law, that's a 62-day duration is set between when the application is deemed complete and the public hearing. Site plan review, the public hearing is discretionary. Often the solar laws, the local laws will require it even for site plan review. For a special use permit, a public hearing is required. So those are held in parallel. There are board deliberations, there are questions done. And I think there's an opportunity with these board deliberations, and I think we'll get in, Mary will get that into that in a bit and further along, where it may make sense for solar projects to bring in folks like the fire code officials, emergency responders into the process, have them review and just comment on the application, especially the site plan with respect to certain code issues. This will prevent rework in the field and the need for amendments. And then finally, also parallel to all this, and is the county planning referral, the General Municipal Law 239M referral that may be triggered. Again, 239M has specific triggers that require that referral to county planning. A lot of counties will, the special use permits are a required referral regardless of where in the town that it's located. So, you know, more often than not, there's a county planning referral for the solar projects in the towns in the central and western New York. After the public hearing, again, following the town law procedure, it's a 62-day process between the public hearing and the need for a decision. And there's 3 choices on the decision. One is it can be approved as is with no conditions. You know, you get the approval and you go to a building permit. More often than not, the approval is with conditions, and conditions are specifically allowed under both the site plan and special permit processes under the town law. I think it's important in the conditions it provides additional enforcement mechanisms to ensure that things like the operating and maintenance plans, the landscaping plans, final consultation and approval with fire chiefs and such, that, you know, those are laid out as prerequisites to getting the building permit. They would not be discretionary decisions, but, you know, those boxes need to be checked before the building permit is undertaken. And then finally, a permit can be denied. So that's the overall process. I think the key here is looking at the local laws, which in what uses had a webinar on local laws recently that you can look back to, you know, and to look at your site plan approval processes. Are there places in there where you want to specifically reference an engagement with, you know, an opinion from fire chiefs, emergency responders, and such? You know, are the application requirements specific? Are the criteria that you want to use in your site plan review and your procedures, are they clear? And are they, you know, is it clear who's the approving body, what the timing is, and what the requirements are? So that's a quick review, kind of a baseline of the site plan process. There's a lot of nuances to it, obviously, but we just wanted to kind of set a foundation for the next discussions in the presentation. So Jenna, back to you and over to Mary.
Thank you so much, Dwight, for that informative presentation on site plans and special permit for solar projects. Next, we have Mary Steblein, who is a project manager and civil engineer at LaBella Associates. Again, for more detailed bio, please go to the chat to read more. Mary, are you with us?
I am just trying to get things coordinated here. Sorry about that.
No worries. Happy to have you.
All right. No, I'm sorry. I am sharing the wrong screen. Okay, good evening, everybody. I'd like to go over some considerations for site plan and special use permit review. Just a few notes to start off. This training is focused on solar energy systems. These are anchored to the ground via a pole or other mounting system detached from any other structure that generate electricity for on-site or off-site consumption. And specifically, we'll be talking today about systems generally less than 25 megawatts. Anything up to 24.9 megawatts can be reviewed. Well, between 20 and 24.9 megawatts might be reviewed under the 94C regulations or by a town. Anything over 25 megawatts must be reviewed under 94C. So what we're looking at today most likely is applicable to systems less than 25 megawatts. I would also like to stress, and Dwight mentioned this as well, it's kind of a recurring theme, that we recommend referrals to others during planning, during the plan review. As many items as can be discussed during that review, you end up with a better product overall. So referrals to emergency management, such as the fire chief, first responders, the fire code official, ask them, can they get around the site? Yes or no, kind of dictates what should be considered and perhaps modified in the review. Also during this training, I won't be focusing on many of the items that would be discussed as part of seeker. Dwight referred to this as well, and it looks like within the chat, you were provided a link for seeker that's specific to solar projects. So I don't want to repeat that stuff too much, such as wetlands, ag lands, visual simulations, and mitigation, including screening, landscaping, glare analysis. Certainly these things can be discussed during site plan review, but should really be addressed during the seeker process. And where possible, we recommend using seeker to modify your application rather than trying to capture it in the conditions, though we will talk about site plan or special use permit conditions towards the end of my section. I also want to stress that there are 3 timeframes to consider. We have to think about what's going on during construction, the solar energy operation, and then we need to consider the decommissioning process. I thought I'd start off with or continue with a little bit of the basics of a solar energy system. So the components of the system include panels, that are supported by posts and racks generally. There may be underground and some overhead conduit that connects everything together. This may lead to certain equipment on the site, such as an inverter, a transformer, potentially battery energy storage systems. And then there needs to be some interconnection to a utility that will get the energy that is generated here into the grid. There are a kind of a long list of site design components that are very particular to these solar energy systems. We would need to consider any setbacks that would be in the zoning code, any wetland and ecological boundaries. There is the ability to mount some of these systems within Army Corps federal wetlands. So you may see some arrays sited within wetland areas. But generally, you'll see that wetland areas are avoided if they are state wetlands, both the wetland area and the wetland buffer. There need to be provisions for tree clearing and shading. So you'll often see a 120-foot radius for trees to be cleared. Every site will generally have an access road that will connect from, whatever major highway or road you might be on throughout the site. And there might be potentially a road that's used during construction and then potentially a road that is replaced for the post-construction timeframe. Gates and fences, it's pretty typical to see a fence all the way around the arrays with appropriate gates. Screening and landscaping, an interconnection point, as I mentioned before, equipment pads for that inverter and transformer, a staging area where there might be materials during the construction of the facility, and then stormwater management might also be an important consideration for many of these sites. I just have here a site plan example, just to give you an idea of what you might expect to see. We've got the road out here, an access road that travels through the site that will allow access to the major components. You'll see this one has a turnaround for emergency vehicles. There's this magenta fence. The arrays have not been sited where there's wetland areas. These long rectangular symbols represent the arrays. And we do have a point of interconnection over here where this system is connecting to an existing utility. Okay, some of the other things you might be interested in when reviewing a site plan. There are several options for mounting systems. You might have a traditional ground mount system, such as what we're seeing in the picture here, which could consist of direct embedded posts, which are generally steel that are driven into the ground. We want to consider the geotechnical information that might be gathered for this site. Where's bedrock? What type of soil is it? Because the soil friction is what is providing the support for that direct embedded post to be in the ground and stay in the ground despite wind events. There may also be other foundation systems such as ground screws, helical anchors, and then potentially concrete piers and ballast if you're, for example, on a landfill cover and you can't penetrate that cover. So DEC has put together some stormwater management guidance that is specific to solar facilities. This guidance was put together in 2018. There is a memo out there. There are some additional interpretations that aren't really captured anywhere. You have to perhaps ask for some of that information. But it is likely that most of these projects will disturb more than 1 acre, which means they're subject to the speedies permit for construction activity, stormwater discharges from construction activity. So DEC has put together this guidance that I said is specific for solar facilities, and it is based on Maryland DEP guidance for the disconnection of non-rooftop runoff. So for example, if you have a length of flow in between 2 panels, the DEC interprets that as adequate space for runoff to come off the panel and get down into the ground, and as long as you have a good ground cover, existing vegetation, for example, the DEC does not require post-construction practices for the area that is covered by the solar panels. So as noted on that slide previously, for certain slopes at facilities, that will work and be reasonable. For slopes greater than 10%, ground slopes greater than 10%, there are some other options for how you can deal with stormwater on your site and still not necessarily have to have post-construction stormwater management practices. You could use, for example, this flow spreader option or the water bars to help spread out that flow that's coming off of the panels and still deal with it by using the existing vegetation at the site. Along with stormwater management, we often think of erosion and sediment control practices, which would be part of a project SWIP. I just have a couple of examples here from some other projects. We have some reinforced silt fence at a stockpile. And that stockpile is both partially vegetated and temporarily stabilized with straw. And on the right, we have a silt stock with stakes. You'll often see these used as a perimeter control practice. I'd like to point out those stakes aren't really 100% correct according to the Blue Book that we work with here in New York State, but there's also a lot of vegetative buffer there, so probably not the end of the world. So you should be reviewing erosion and sediment control practices on the plan set. The designer of the practices should be showing the minimum number of practices to minimize erosion and runoff of sediment. But we like to think of the SWIP and erosion and sediment control practices as kind of a well, the SWIP is a living document and it's a dynamic situation. So all of this is subject to field conditions and needs to be adjusted as necessary. So continuing on with some erosion and sediment control measures, I have an example of a staging area, what that might look like on the left. And then on the right, we have a stabilized construction entrance. It looks like there's a little bit of dust tracking off of that site, but not too bad. Most of the dirt should be shaken off the vehicles within that construction access. So another component of the stormwater management that should be considered, the DEC has approved this limited use pervious access road for renewable energy projects in New York State. I'd like to point out this is not suitable for construction use. This can only be installed for post-construction use. It would get perhaps a little dirty and less usable, less functional if it was used during construction. DEC has several different options for different sloped roads. However, while they recommend what you're seeing on the screen for 0 to 10% slopes, we actually think it needs a little more design consideration and needs to really be vetted by the engineer on the project. If it's considered for greater than 5% slope, you would probably need to consider stepping the subgrade material. So just something to keep your eye out for. So if you see this limited use pervious access road on a site, it would mean that no post-construction stormwater management practices are necessary to treat any runoff from the road because it's not considered an impervious surface. So there is an advantage in that, and that's why we often see these roads considered for use. So if the limited use pervious road is not used, then you will likely see a gravel road in these facilities, and that would be considered impervious surface if it's a compacted gravel road, and therefore would need some kind of post-construction practice to treat it according to the DEC. Many codes are written to minimize the impervious surfaces on these facilities. So you'll often see this road potentially being one of the very few impervious surfaces, if it is indeed even included. We suggest that the access road would be a 20-foot width if it's an improved access road. Unimproved varies from 15 to 20 foot. Again, all of these items kind of need to be verified with the emergency response that will be responding to these sites to make sure it's appropriate for what their requirements are. But if we were looking at strictly just equipment going around the site and tractor trailers delivering materials, we would consider a 45 to 50 foot radius on any turns in the road so that they can adequately turn around the site. HS20 load rating, again, geared towards the equipment and trucks. That may be something that the fire code may have an impact on. The roads need to have adequate drainage, and again, emergency response should be pulled into all of this. And I just want to make a note of interpretation of the fire code. I have seen in some locations that if there is no building present at the site, then the fire code official has indicated that the fire code requirements for fire apparatus access roads are not required, but that decision really has to come from the fire code official and is subject, to whatever the municipality says is necessary. As I mentioned earlier, it is typical to have an inverter and a transformer on these sites, and there may be battery storage. And these pieces of equipment are typically on a concrete pad, and that concrete pad might be the only impervious surface that's created at the site. And stormwater management is necessary. Treatment is necessary for this impervious surface that's often taken care of using a vegetative filter strip, or there are some other stormwater management practices that are appropriate for this. Just want to also make sure that if filter strips, these vegetative filter strips are used or designated on the plans, they can't be located under the panels. We've had clear guidance from the DEC that would not be a suitable location for those filter strips. Fencing and gates, again, we really want to make sure there's feedback from the fire chief and emergency responders in locales about what is appropriate, but at a minimum, we think that a 24-foot wide primary access gate is necessary. Ideally, there's a 20 to 24-foot wide secondary gate as well, somewhere else within the fence line. Any additional ingress or egress that's required. Some places require man gates at a certain spacing so that people could get out if there was a need for some kind of emergency response. The National Electrical Code requires a 7-foot tall fence around here, so that will probably be the minimum fence height that you would expect to see, and that may conflict with existing zoning codes. We suggest minimizing concrete abandonment to just the corner posts where possible, and in wetlands to drive those fence posts in an extra foot in order to minimize the amount of concrete that's associated with these fences. That becomes something to be considered in the decommissioning plan, because all of this will be removed at some point, and the more concrete you've put in the ground, the more challenging it is to get all that out, the more disruptive it is. And another option with fences that I wanted to mention was potentially winged slats that can provide that visual screening. Might not be, what you're looking for, but it is an option to consider. So there is some soil disturbance on these sites. There's not mass grading anticipated like you might see in a residential subdivision or in a major commercial development. These installations, as you may have seen throughout the pictures, generally will follow the land as it's graded. But restoration will still be required in the site wherever there has been soil disturbance. And this might be seed mixes, trees, and shrubberies. It's ideal to have some kind of species variety within those seed mixes and trees and shrubs. Inside the fence, something to consider might be a pollinator seed mix to help the bees out, or another seed mix that's limited to 2 to 3 feet in height. If it is something that's growing tall, there may be some considerations that the emergency management services in your area, they may want to see something like regular mowing so that the vegetation doesn't grow any taller than 10 inches at any one time, just as a brush fire consideration. Outside of the fence, a standard seed mix might be used, whatever is appropriate for your locale. And just a note that coverage under that speed each general permit can't be terminated until there's uniform 80% perennial vegetative coverage or other appropriate final stabilization in place, such as your gravel access road or some other permanent mulch surface. So just wanted to touch base on a few special use permit conditions that you may want to consider with these projects. You want to protect most valuable or productive farmland, and the way you could do that is potentially by avoiding installation in particular areas. You want to consider what provisions there might be for substantive changes that may occur. So when it comes in for building permit, what happens if it's different from what you reviewed during the site plan and special use permit review. There may be some conditions around provisions for inspections, and those could be related to SWIP enforcement, and that can also be tied into restoration requirements. There's a lot of options that might be considered for inspections. Conditions might be appropriate for particular working hours and any noise restrictions that might be applicable. Construction traffic plan, including truck routes or signage around the area, whatever might be appropriate, that should be discussed throughout this planning process. The road use law, there may be unfortunately damage to existing roadways, depending on their existing condition and related to the construction traffic. So we would suggest potentially a pre and post inspection if that's something that is of concern to the local highway departments. There may also be provisions for working with the town board on the decommissioning plan and the appropriate surety that may be associated with that. And there may be specific emergency response requirements that you want to include in there, such as a Knox box for emergency response right at the gate. So that's the end of my portion of the presentation. I have my contact information in here, and I think we're moving along.
Thank you, Mary, for your review of site design components, mounting systems, storm and sediment management and control systems. Next, we have Rudy Saporite, Catherine Kelso, and Gerry Blau from IBTS. Rudy is the engineer program director at IBTS, holds certifications in solar, photovoltaics, infrared thermography, building envelope, heating and air conditioning, and quality assurance. Catherine is an electrical engineer with 16 years in the solar PV industry. She has extensive experience in installation, O&M inspection, and quality review and providing trainings to industry professionals. Gerry is the NY Sun project manager and a dedicated professional with over 23 years experience in the design, engineering, and construction of both commercial and residential photovoltaic energy systems. For more detailed bios, please go to the chat. We're happy to have you all. Thank you for joining us.
Thank you very much, Jenna. This is Rudy Saporite, and thank you all for attending this evening. I'm floored to see the number of attendees at 200, nearly 200. So thank you very much. Get the very proud opportunity to allow some of my program managers to speak. But before I do that, a quick introduction. I'm the program director here at IBTS's Energy and Sustainability Group, and we oversee inspections throughout the industry for various different clients, from NYSERDA through private clients in private industry, Mass Clean Energy Center, and elsewhere. IBTS is a 501c3 not-for-profit organization that's managed by a group of board organizations, board of directors, who guide us to provide unbiased professional services to municipalities and government agencies in an effort to enhance the communities for which we work. Throughout the last 10 years, we've overseen the inspections of PV systems throughout the United States, and for the last 4 years here in New York State under NYSERDA's New York Sun program. The data, or the process that we use, is one that inspects systems and then relies on the data and data analysis to give us various different insights into the quality of installed systems. And from there, we use that information to maybe train code officials like yourselves or various different stakeholders throughout the industry. We oversee similar efforts for the Department of Energy nationwide based on the the strong feedback from this type of a process. I'm going to get into speaking a little bit more, or my team and I will get into speaking a little bit more about the inspection process, specifically for the long-term goal of that inspection result, or that inspection detail and feedback really is a feedback loop that should be feeding back into the front end of our process. We all know the process of originating and then installing and inspecting solar, and then it seems to die at the end of the inspection, and we've got a record of potentially failures or deficiencies that we've measured. And sadly, throughout the last 10 years, I don't know that I've seen any measurable increase in quality. But one thing that we have done is started to tip those wheels towards the quality side of things. Really, again, by providing that feedback loop and making this data more available to individuals in the industry. So today, what we're going to address is sort of our top 4 failure categories. They are system labeling, wire management, penetration and enclosure integrity, and system and equipment grounding. And they are rated, or at least they're presented to you in order of their prevalence percentage-wise over the subset of inspections that we've overseen. The data that we've comprised here also is a representative sample of about 700 or so PV inspections done in New York State under NYSERDA's NY Sun program. And every single one of these inspections that we have completed or that data was recorded on was done post AHJ inspection. So when we as the code officials, when we as the authority having jurisdiction leave that site, and between 6 months and a year later, somebody like Gerry or Catherine come back to inspect, whether these issues were there at the time of initial installation or just found during the final inspection, they again are prevalent on inspected systems or quote, commissioned systems. I'm going to glance over system labeling for one, because I don't think it's more or less the largest measured failure due to any other reason than they're typically not done at the time of installation, or excuse me, a post-installation inspection. And maybe because of that reason, we see a high level of failure on them. If you get as you all know, if you get a passing grade with no labels, unless you have a very, very responsible process, you are likely not sending anybody back to install those labels because you already have an approved system and a permission to operate.
Sorry to interrupt, Rudy. The slides are not moving. Do you mind putting in presentation mode?
Oh, I knew something was going to happen like that. Let me try this. Stop share. Okay, let's try that one more time. Share screen. Here we go. Do you have a visual?
Yes, is on wire management.
Excellent, thank you. I will just jump back. Okay, so here's the graph I was showing earlier. Apologies about missing out on the IBTS board organizations, but in the interest of time, I will not go back a few more slides to the start of that. Again, getting into the meat of this, here's the pie chart I showed earlier. When you couldn't see it, apologies. Again, the variation in these percentages here, we show on average system labeling occurs 41% of the time incorrectly. But that's a computation of roughly 5 to 7, actually in labeling, it's 12 labeling questions that ultimately are scored, creating an overall average for the labeling section. And you'll notice that same type of process with each set of data. Wire management has approximately 20 questions or so, and the variation of those fail between 10 and 41% of the time. This is probably the most prevalent failure that I'd like to draw everyone's attention to for the sake of considering 10 years worth of industry data has not gotten nearly 1% better in regards to wire management or deficiencies related to wire management. And that's pretty obvious, right? When we're looking at these panels, there's thousands of panels in a system, 2 wires per panel, and they connect to some trunk lines that ultimately create raceway back to the distribution. So with that much customization or that much component available in your system, it's no wonder that ends up being the bigger issue on site. Again, labeling, because it occurs most often, but I won't say it's not a safety consideration. It's absolutely a safety consideration, but given that I only have 30 minutes of time, we're going to skip over labeling. I'm going to leave this slide, as well as identify the industry has created a number of different labeling requirement infographics, including IBTS having provided one, but Hellerman, Titan, everyone else that I think creates labels has one. There are ways to educate us about labeling, and we should be including this in our application process, requiring this in our plan submittal, ensuring that it is correct during plan review, and then checking for those, ensuring and making sure that they are installed before the post-installation inspection is called. Typically what we see wrong is handwritten labels with either marker or illegible information. Maybe the labeling isn't present at all, or the values themselves are incorrect. Given that we're working with systems that are running DC current as well as AC, in many cases, we potentially are misidentifying the type of power that is otherwise being guarded by the conduit or being identified by the labeling, and or they're not suited for their environment. These are all conditions, again, that we have not seen a lot of improvement over time, and we do believe it's partially due to enforcement. Again, nobody's going back to the site to install these labels, so let's try to make sure they're there post installation inspection. Really where the rubber meets the road for me is in the term of safety, or the long-term safety of a system as considered by wire management, or the safeguarding of the current carrying conductors. Where we see this fail, and some of the bigger issues, are where conductors are in direct contact with abrasive surfaces. Maybe we're misidentifying the conductor by using the improper colored wire insulation, or otherwise not keeping that consistent throughout the system. Oftentimes we'll see AC and DC conductors sharing a trough in commercial situations where maybe we're being installed on some farm or some pre-existing tie-in effort, where maybe I lay some final home runs into a shared trough, which is absolutely not allowed. No bushings used at conduit entry, conductors themselves not protected from prolonged exposure to UV, and overall splice and connector compatibility. This is where I'd like to take a moment to introduce Gerry Blau to walk you all through the various things that we caught in New York. Again, Gerry oversees the program as the New York Sun specific program manager, and Catherine is a part of his team, as are a number of different desktop reviewers. So Gerry's going to get into walking us through the visuals associated with wire management, and then we'll transition over to Catherine to take us through some structural and other considerations. Gerry, can you test your mic to make sure that we can hear you?
Can you hear me? Thanks, Rudy.
I can, sir. Thank you very much, and please take it away.
Thanks for the introduction. Hello, everybody. So I'll just get right into it. I guess you're seeing the pictures here. You know, as Rudy mentioned, you know, our work and experience in the field, doing these inspections, gathering this data, consistently demonstrates that wire management is a challenge in the industry. You know, we always consider or think about what, as Rudy mentioned, what can be done to improve this. And there's a whole range of things. I'm not going to go over all of that, but I did wanted to mention a couple of terms as we go through these pictures. One is a qualified individual, and the other term is a workmanlike manner. And as we look at a few pictures here, just keep those terms in the back of your mind and consider if, you know, these things are fit within the guidelines. You know, workmanlike manner is not a defined term in the NEC, but qualified individual certainly is. So in this first picture here, you can see the bundling of the wire. There's an excess amount of wire that often happens, and we often see this in commercial type installations, you know, bundled up in that way. Now there's likely a good reason for that excess wire. Many installations for efficiency purposes will have pre-made wires that are labeled and cut to a specific length, and they're terminated on either end. So in the ordering of those wires, they're probably, you know, over providing lengths that are longer than needed because they don't want to have to come up short. That's a pure conjecture, but there's really no other reason to have that type of excess wire bundled up like that. So to manage it properly, you can argue that that is a proper management of it. There's certainly a lot of commercially available equipment that can probably do a better job of managing that wire, considering the length of time that an installation like this is meant to be in service. Using zip ties and hanging a bundle of wire like that will certainly serve the purpose for some amount of time, but there's likely better ways to address that type of scenario. The second picture you can see is just a bundle of wire hanging loosely, clearly not something that's code compliant, definitely not something I would consider a workmanlike manner. Third picture there showing the overgrowth, the vegetation. Mary mentioned earlier some of the, techniques used in controlling vegetation. Wire management as it relates to vegetation can be a critical factor because of, as you mentioned, brush fires could be a problem. But certainly protecting these wires from physical damage, whether it be an animal coming into the installation or the weather, snow, certainly here in the Northeast, there's plenty of that. And, just general maintenance of the site. So if an installation has wiring in this, that you can see it this way, it's conceivable that when the person coming out to do vegetation management, take care of that, could run into problems when there's wire installed that way.
Yeah, actually, if I may, the red, good point, Gerry. And I think the reason we kind of picked this one is because it seems they made an attempt to manage the wires. Those red connectors are a wire management solution. They bundle wires. And given the angles and the various hooks and L's and brackets mixed in there, it's intended to be used along the backside of the array, essentially to hang wires and maintain wires throughout the bundle. It is not intended to essentially span between two arrays and hold the weight of any kind of wire structurally, whether it's a vegetation management or even, some type of deer or wildlife that's running through there. Suspended conductors spanning multiple feet are not safe and certainly not rated for that prolonged exposure or to be laying direct contact with the ground. Sorry, Jay, go right ahead.
That's a good point, Rudy. And that brings me to the, back to the term of qualified individuals, workmanlike manner. Circling back to the front end, the purpose of this, the plan review, things to consider up front. I have yet to, in all my years of doing this and in the many installations that I've installed on and inspected and been on and managed the process, there's never a wire management plan, something that takes into consideration all of the aspects of the installation, the specific site conditions, whether that's a fixed ground mount, a tracking mount scenario. These things are, typically,
Sorry about that.
plan set, or there's the detail that covers trench details, 3-line diagram, all these components of a plan set, but none have I ever seen that show a specific wire management plan. So just a case in point, if, as it was mentioned earlier, the array is going to follow the land. So you'll often see breaks in the array that necessitate some elevation change from one array to the other. In that sense, how is it that the installation, during the active installation, how do those people deal with that separation of arrays? You can see here on the left, there's some extra slack that is put into the ground wire. The others are a little bit tighter. If you can see a little bit closer, you'd notice that there's some method that they used for abrasion resistance. The second one over to the right, picture there, you can see that the wire is much more taut. So if the arrays were to move independently for some reason, whether it be erosion or some other expansion contraction event, it's possible that those conductors are going to fray over time. Not only possible, I would contend that it's likely that that will happen over time.
Good
So
point. There's no scutcheon or wire chafing sleeve there to keep from allowing those conductors sitting in bare metal as well.
there's a variety of methods commercially available to accommodate that type of a transition. The point really is, are these methods identified up front and considered up front in the context of the site-specific conditions, the equipment being used, as I mentioned, the tracking device or something like that. So it would be an important consideration up front to see what equipment is being used and what the plan is to manage the wiring. As Rudy mentioned earlier, there's a great deal of wiring contained within any array of this size. It's a redundant task for the installation crew to, wire one module to the next, and to manage every piece of wire along the way. It's something that, really takes effort and conscious, deliberate action to manage properly. So it goes back to not only, plan up front that demonstrates to the installation personnel how to adequately and appropriately manage all that wire, and that they have the equipment to do it. All of these things can be identified and put in in the plan set, just as any other detail is, along with alternatives to that. If they encounter certain topography changes and they can't, one form of wire management cannot be used appropriately, then there's a backup alternative that they can use that's already part of the plan set and approved in advance. One other thought that I had, there's a term used out in California, responsible managing officer or responsible managing employee. And I would guess that if a plan set and the plan review, certain key individuals were identified as those responsible for certain tasks, and in particular wire management, it may at least make the builder more cognizant of accountability for these types of things. There are plenty of pictures that demonstrate and show good wire management. We're focusing here in the short amount of time on that, those issues that represent poor wire management because of the frequency in which we see it. As Rudy mentioned, it's the second most often cited deficiency in commercial and residential systems. So you can see here a few more pictures. This is on the left, a tracking system. The ground wire that you can see there is solid. After repeated back and forth tracking, day to night, every day, 365 days a year, that wire will likely eventually break. So just circling back to the upfront plan review, identification of the products that are being used, and an actual plan that with the associated detail that can be used by the installation crews would go a long way in helping these deficiencies diminish over time. And certainly accountability is one method that would be promoted by upfront identifying the people that are responsible for this and the methods by which they plan to deal with wire management. With that, I will pass this over to Catherine.
Actually,
Rudy, you're on mute.
I missed that button. I'm using my touch screen. Sorry, before you jump into Catherine, I did add another slide. I snuck it in, but I know we're kind of getting close on time, so I don't want to do too much chatting. I will point out that a tracking system adds movement, and traditionally people look at PV as a non-moving system, a system with no moving parts. When we start to add movement, we start to complicate all these things. Beyond complicating things with movement, we have just conductor or component compatibility considerations. One of the two most common issues that we find that result in a thermal event or a negative outcome is improper management of wires, loose connections, or improper terminations, non-compatible connectors. Here you see two types of connectors. Now these things look almost identical. I do know that from just looking at this here. You've got a sleeve and you've got 2 points, a male and a female. When you hold them together, they actually are not that similar. They do not work together, and this is known as an amphenol or MC4 connector. They are not compatible with each other despite looking this similar. So where you would likely see this is on the transitions from the component to the home run. So where they're taking the pre-wired leads from the PV array or the PV module, and they're transitioning to their home runs. This is a critical point that needs to be addressed during plan review and ensure that conductors and module connector compatibility is considered on the front end. And with that, I'm sorry, because I guess we're not technically over time. We are coming into the QA session. But last but not least, actually one of my favorite individuals to talk to on my team, Catherine Kelso, licensed, or not licensed engineer. I think that's what she told me she was going for. Electrical engineer who's done more than 3,000 inspection reviews for us, has been in Camp Pendleton doing touching, installing, and everything else with these systems. And I think has an extreme wealth of knowledge in the commercial sector that she's hopefully going to offer to you all now. Catherine, without further ado, I will shut my mouth.
Thank you, Rudy. And I promise I'll go through this quick because I know we're running short on time. So we talked about wire management issues. We're going to talk about a few other of the more common failures. Conduit and enclosure integrity, things like this, where you've got the freezing water inside the enclosures. First of all, it's could be on some of these larger systems up to 1500 volts DC power going through there. You don't want water anywhere near that. And second of all, the freezing can break the enclosures and cause even more problems. We also have issues with enclosure knockouts. So they make a hole, they stick the wire through it. There should be some sort of strain relief or conduit fitting to not only hold the wires in place to protect them from damage, but also to keep water out of the enclosure or pests, small animals, bugs. Little mice love to make nests inside enclosures. Just making sure conduit is tight. It happens more often than we'd like to talk about, how often we go to a site and our inspector just hand checks a few pieces of conduit and they move. The fittings are not tightened. Frost sleeves on conduit that goes underground is a big one, so that when the ground moves as it freezes, the conduit stays in place or can move with it instead of staying in place and cracking and breaking. Or just general conduit management. We've got our picture here of conduit being held up with plastic wire ties and just kind of dangling loosely where it goes to the next enclosure. That will not last the 25-year life of this system. So that needs to be dealt with. Yeah. We also have a lot of structural issues that we see. The top left there, we have an array that's sinking. Mary mentioned about doing soil tests before starting these projects, and that is huge. The soil is the only thing holding these in place, whether they want to sink or whether the wind wants to pick them up and lift them out of place. The soil has to be right, and the piles driven in have to be right for the soil. So all of that needs to be checked before you install so that you don't end up with things like this, which is a sinking array. Mary also mentioned about vegetation, and it is very important that the vegetation stay under the level of the array, or be mowed and taken care of. Otherwise, you have things like that was actually a tree that had, over the period of about 2 years, grown not only up in between the panels, was stressing the panel, stressing the rack, and shading the entire array. Also, taking care of slopes. You can see the bottom left there. We have the one odd array that went up on a slope because they didn't grade properly for it. So that one's just kind of out of whack. Also, the racking being installed properly. We've got a mid clamp that is not tightened down. And usually if there's one of these, there's hundreds of these in one of these large arrays. Sometimes an entire row gets missed. And you can see it's just not holding the panels, which means those panels and their frames are flapping in the wind, which is not a good situation. Next slide, Rudy. So yeah, go ahead.
Yeah, I was going to say, this is sort of the understanding. We're all looking at sort of, oh my gosh, this stuff is on the projects that we've all participated in. We really wanted to come here with more of a constructive opportunity to improve. The inspections need to act as a feedback loop so that we can affect the front end of the process. And as UAHJs and local stakeholders, representatives are coordinating on how to better engage with environmental studies, fire marshals, and the local public to ensure the needs are met. It's also what can we think of to address the current failures that we have not built out of the system. So one of the things I could thought of was kind of an actionable, what can we do to improve? The considerations for future improvement during plan review and application requirement process that would benefit or promote a reduction of failures downstream. So to review your process for application and approval, what is the order of process? Does the electrical engineering and review happen before an environmental study? Does the fire marshal not get a chance to weigh in until the end and otherwise is seen as a curmudgeon who's just ruining everybody's profit margins? What authority or what position do we have to require different literature or different infographics? A more robust process is presented to the installer during the pre-application effort. So they're prepared to get a geotechnical survey, do core samplings, and make sure that before you even present to me an engineering diagram that I waste a bunch of my staff time overseeing, can you even install on this site before we even go through engineering considerations? Require electrical drawings provide details on wire trays or cable management systems that are intended to be used or intended to be approved for use on site. This is not a what if. This is a guaranteed consideration. Wires are part of the system, and the idea that during the plan review process or during our 3-line drawings, we have no detail and we leave it up to, quote, that qualified individual who does not have a budget to buy additional materials, who doesn't have authorization to change the work scope, to go ahead and somehow manage that in the site. No, that needs to be figured out on the front end. And that needs to be included in the electrical drawings and requirements for applications. Required selected components include cut sheets and schedule of compatible components or connectors. So this is the additional follow-up to requiring a little bit more information. There are detrimental outcomes to improperly installed systems. So understanding that a component can be installed adjacent to another component. I mean, when we're doing HVAC, we know very easily I can't be this close to a window or this close to an exhaust surface. But when we get into a situation where we're installing a PV system, are we aware that this rack doesn't work with this module or this grounding component is not eligible for use on a certain component? The last thing that I'd like to present also is to review component selection to ensure proper material compatibilities. Build out the idea for galvanic corrosion. This typically is most prevalent in very chintzy, cheap, oftentimes improperly sourced grounding components. The one safety lug that's bonding your rack could potentially be not tin or properly plated, and thus corrode your grounding conductor and leave your system essentially unsafe. So with that, those are a few things that you all can do to improve. I really do thank you all for your time. From us at IBTS to you, we are here to assist. If you are in an environment, a rural part of New York, there are third-party resources that can assist, whether it be IBTS, somebody off the New York State underwriters list that's approved to provide inspections in New York, or various other organizations that we know are very professional in New York. Thank you all very, very much for your time, and I believe that brings us to the QA section.
Thank you so much. We have quite a few questions. We're going to go ahead and get through as many as we can with the time that we're allotted. We're going to go ahead and start. This is a question for Mary. It's a little bit of a two-part question. Whenever you are ready, just let me know. There we go. The question is, should municipalities only allow ground mount arrays in certain soil types? Because most zoning laws only address prime ag soils, but not the structural integrity issues. And is there a trade-off between soils that provide good support for ground mount arrays and those that are conducive to healthy vegetative screenings?
Okay, why don't we go in backwards order, because I can remember the last part of that first. Certainly, I mean, I think there's going to be a lot of different options. There's a menu of options that you can choose for the way that these posts or whatever the particular system is for ground mounting, if that's even the option to go with, right? There's a few different ways to get this system attached to the earth or on the earth. And I guess that's something that really has to be addressed on a case-by-case basis by an engineer, by somebody who has access to those soil borings or whatever geotechnical work is done. You can be guided by some of the soil survey information, but we really need to see that information from the actual site to have a good idea of what is appropriate. And that's where potentially an engineer's review can be pretty helpful to a municipality during the process to give some advice on what's appropriate. So that being said, I mean, there might be different ways of anchoring into the soil. So it doesn't necessarily, it's not necessarily tied into what's also going to support healthy vegetation. Again, much like there's lots of different ways to put posts into the ground or options for that, there's different vegetative mixes for different soil conditions, or I mean, with the limited amount of soil that's being disturbed, hopefully at some of these sites, you know, maybe there's soil conditioning that you can do. I mean, there's a lot of ways to get around it. So I don't think you're limited to a particular system based on the soil type or the vegetative type. And if you could remind me of the first part of that question, I'm not sure.
Of course, it says should municipalities only allow ground mount arrays in certain soil types, since most zoning laws only address prime ag soils, but not the structural integrity issues.
Maybe I could take a stab at that one. I think, you know, so site plan and zoning is about the use of the land, right? And so, you know, there are regulations regarding agriculture because there's an objective to preserve agricultural land to the extent reasonable in balancing other competing uses. Zoning something out because of structural issues, you'd kind of have to get a rational basis, say, to the use of the land in order to come up with that. I think that would probably require a rather comprehensive survey of the town to do that. And I think there might be other methodology you could use to accomplish similar goals, such as using seeker and, you know, whether, you know, I think there was a project that Mary and I have been involved with where, you know, you want to ensure that there's not a significant adverse impact from structures being put in the soils, so that, you know, the geological information, geotech information is necessary for that. So kind of linking it to the potential environmental impacts can perhaps accomplish a similar objective.
Just a follow-up for you, Dwight, there was another question asking if you can force the developer to run an impact study on water runoff from the site prior to approval, since steep slopes, hard clay impact runoff is way beyond the simple examples that were shown in the presentation.
Yeah, so I think, again, that goes back to seeker. So surface water management is part of the seeker assessment. Understanding the fate of the surface water runoff is certainly part of that seeker review. So to the extent that additional information is necessary to make that assessment, and again, this is where I think it's important to have the right technical team assisting the reviewing boards with the site plan or special permit review, but that can be linked into the seeker process to ensure that that as presented, the project has has surface water management that doesn't adversely impact the surrounding areas. So yes, you can do that. It would have to be linked to the seeker process and specific site issues. I don't know that you could do a blanket. You have to do a certain requirement, but if the linkage is to the surface water management in the seeker process, I think you can certainly do that.
So I can also chime in maybe from the SWIP perspective. I did provide some of that guidance from DEC. If you're not seeing the entire document still indicates that you need to prove that you haven't altered the hydrology from pre-development to post-development. So the soil is essentially going to stay the same. So when the person referenced the clay soils, I mean, that soil is not effectively changing from the pre-development to the post-development condition. So there's not a lot theoretically that's changing when you run that hydraulic analysis. And that would all be part of the stormwater management report or what's feeding into the stormwater pollution prevention plan. So somebody's got to put all that together. They have to run some kind of a stormwater analysis in order to meet the requirements of both the general permit that's applicable here and the particular guidance that's appropriate for solar developments. I didn't mean to oversimplify it. There still are requirements for that modeling to occur and for those results to be part of the SWIP.
All right, my next question is to whomever can answer this. Do you know what entity will be AHJ for Section 94C, Office of Renewable Energy Siting Projects? AHJ for Section 94C.
AHJ. Could you repeat the first sentence again?
Is that the authority having jurisdiction?
Oh, I'm sorry.
Okay, sorry, I don't know that acronym.
Yeah, sorry, that's just your municipality code official and varies who it is.
So the permit authority goes to ORES, but usually there is a proposal as part of the applications as to who that would be. Often it's negotiated with the municipality, or it's negotiated where there might be a third party code compliance that is engaged by the developer and the municipality has an oversight role of that. But I think typically it's a negotiated thing, but ultimately it's an ORES responsibility because they have taken the permitting authority for the 94C projects. But not that they have, I think, necessarily a staff to actually administer it, but the process, the approval for how that is done is in 94C through ORES.
Which entities are inspecting systems for deficiencies like wiring? Can municipalities rely on utilities and/or NYSERDA to make sure systems are safe? Most zoning codes require adherence to NEC or other standards. Is that sufficient?
If I may answer that, requiring adherence to a code is not a sufficient code enforcement practice. Verification post-installation is really the only way to ensure that the stakeholders are safeguarded or the system is adhering to code. NYSERDA does do a significantly phenomenal inspection. I can say that because it's my team that carries that out. It is done post-installation though, and occurs a period of time after the system comes online. So to say that that would be useful, I would maybe inquire with the team at NYSERDA if there's some resources that can maybe help out in your municipality pre-final inspection or to assist with that final inspection. I know I'm contracted to do several more code official trainings through NYSERDA this year, similar group platform. But IBTS as a quality assurance provider to NYSERDA can provide inspection services. And again, the New York State electrician inspectors are provided on an as needed or on-call basis through New York State underwriters. So if you're municipalities otherwise unable to provide those inspection services, you could always use one of the state approved inspectors that's set up or at least regulated for your area. That can be found on if you just Google New York State underwriter electrical inspection list.
To kind of segue from that, we do have a couple questions about inspections. You did just reference one entity that can adhere to these inspections. So the question is, do building code enforcement officers usually do these inspections? Some have said that arrays are not buildings, they're not covered by the IBC. And does IBTS inspect a site to determine its suitability?
So we don't typically go out on the front end to assess the site. We will be post-installation inspectors. We'd certainly defer work to somebody like Mary or an engineering firm who would assist in your site qualification process. But yes, we would absolutely assist in on-site. I guess for lack of a better term, we can assist on the front end in an effort to create a process to limit the back end. I wouldn't go as far as say we would provide environmental or engineering review service. I again would recommend an engineering firm provide that directly as we stay kind of unbiased. Yes, IBTS can provide those inspections. And in some areas it varies, right? So I know in my municipality, the code officials go out and they look at it, but that's because they're otherwise interested in it. They are looking at a number of different projects to come online for community solar, and they otherwise have the skill set and the bandwidth. I've traveled New York. I've now lived here 42 years. To go from my area in the greater Dutchess County area, say up to Rochester, you're going to pass a lot of rural towns with a very, very low population and potentially not the needed resources to provide that oversight and inspection. So for that, I would say this is kind of municipality specific. In certain municipalities where they have the bandwidth, the skill set, they're absolutely on site looking at these. The New York State Unified Code through the fire code provisions and just the NEC enforcement of electrical provisions, in my opinion, requires that you do a final inspection, whether you hire a third party for that or you do that in-house. It's in my understanding an obligation to close out that permit with an acknowledgement of safe and compliant installation.
Is it possible for a 15 megawatt facility to have less than 1 acre impervious cover and avoid general permit requirements if the DEC previous road spec is used?
So I might need a little clarification on this question. So the need for the general permit or coverage under the DEC general permit for stormwater discharges from construction activity is triggered by 1 acre of disturbance. So it's 1 acre of ground disturbance. As soon as you've hit that threshold, you're subject to that coverage. So I'm not sure if there's some confusion potentially in the amount of impervious cover. I can't say that I've seen a project that doesn't disturb more than 1 acre across the site. So every project that I've reviewed to date has needed coverage under the general permit.
Thank you so much. The last question was, does fencing have to be chain link or can use other wildlife proof fencing?
So I've never seen anything other than chain link be shown in the plans. I suppose that a lot of this is dependent on what the National Electrical Code says more than anything else, because it is also a safety and security issue. It's not just a wildlife issue, but if other people have some thoughts on that, I'm happy to.
Yeah, I think a number of the zoning codes will, I think it's more architectural in nature, but some of the zoning codes will specify some more detail on what's required for fencing from a zoning code standpoint, with the caveat that whatever's installed has to be compliant with the NEC code. But there's certainly fencing requirements in the site plan regs in a lot of towns.
Right. Thank you all so much. We appreciate your time. We'd like to thank all of our theme panelists for their contribution to this event. Their contact information can be found on our website under usesusa.org under the webinars, also in the chat. If you enjoyed this webinar and like to donate, you can also go to our website, usesusa.org, and click the donate. And remember, the Friends of Uses October Grassroots Gathering titled Debunking Misinformation is this next Wednesday, October 27th from 7 to 8:30. And you can go on our website to also register for that. Again, thank you all very much. And that concludes our webinar from this evening.
Thank you very much, Shanna, and attendees.
Thank you all.
Thank you.
Thank you. Thank you.